Hi, I'm Stephen Wolfram, and I'd like to show you a bit about our Wolfram language. I've been working towards what's now the Wolfram language for about 30 years, and big parts of it I've been able to incubate in Mathematica and Wolfram Alpha. But it's only in recent times that we finally had what we need to create the whole Wolfram language and to set up mechanisms to deploy it very widely. We're actually at an incredibly exciting point right now where we're suddenly able to take computation to a whole new level and, in effect, inject sophisticated computation into everything. So what is the Wolfram language? Well, the first thing to say is that it's a new kind of thing. It's what I call a knowledge-based language. It's a language where a vast amount of knowledge about how to do computations and about the world is built right into the language. So right within the language, there are primitives for processing images or laying out networks or looking up stock prices or creating interfaces or solving optimization problems or whatever. And through the symbolic structure of the language, they're all set up to work together in a wonderfully coherent way. Let me show you. One of the great things about the Wolfram language is that if you want to, you can use it completely interactively, even on the web. So you can type something in and immediately get a result out, like this, or like this. Yes, it's fast. Of course, it knows how to factor that number too. It's got all the fancy algorithms built right in. It's also got immediate visualization. It also knows right off the bat, like, how to get your friend network from Facebook. It lays out the network automatically, and it knows all the fancy graph theory algorithms, so you can immediately ask it all kinds of things about the network, like how do your friends break into groups, or what's the most connections any friend has. The Wolfram language knows how to do lots of things, like let's ask it to get the current image from my computer's camera. Ah, that's me. Well, let's edge detect me. I can have it be dynamic too. I can do all kinds of computations, like there's me broken into little squares, and there's me with a random color blended into each square, and now reassembled. The Wolfram language doesn't just know about algorithms and computations, it also knows about the world. Like, let's ask it when the sun will set today. There's the answer for my current location. There's the time from sunrise to sunset in days. We can convert it to minutes. The Wolfram language has a precise way of talking about everything, but when we're dealing with the world at large, we often just want to use natural language to describe what we're talking about. And thanks to Wolfram Alpha, we've built a big stack of technology for doing that. Like we can just ask for countries in South America, and our natural language understanding system can figure out what that means and generate precise Wolfram language code from it, so that we get a list of the countries. And now we can compute from that. Like, let's generate their flags, or let's find the dominant colors in those flags, or let's have a whole little program to make a table of countries and their dominant flag colors. Okay, let's try something more ambitious. Let's get a list of the capitals of the countries in Western Europe. Now let's find what order we'd have to visit these in to have the shortest tour of all of them. Needless to say, the Wolfram language has the best known algorithms for solving a so-called traveling salesman problem like that. Now let's plot the tour on a map as a thick red line. And yes, the Wolfram language has detailed maps of everywhere built in. Okay, well, I've been doing different kinds of examples. There's really a huge amount built into the Wolfram language. You can get a sense of it here. Thousands of algorithmic functions, thousands of domains of data and knowledge. But in a sense, that's just the beginning, because there's so much more power from being able to put all these things together. And what makes that possible is the structure of the Wolfram language and the principles that it's built on. The first really critical thing to understand about the Wolfram language is that it's symbolic. If you have x, you don't have to give it a value. You can just have it be symbolic x. You can type in a formula involving x, and then you can do a computation on the formula symbolically. And of course, this is great for math, but one of the big discoveries of the Wolfram language is that it gives you a way to do a zillion other things too. Let's say you've got some data with a part you don't know. You can just treat it symbolically. What about something like a network? Well, in the Wolfram language, it's a symbolic expression too, that displays as a graph, but you can go ahead and manipulate it symbolically too. Same with 3D graphics. Go ahead and create a symbolic form, render it as 3D graphics. Now, because everything is symbolic, I can just pick up this output and say feed it into an image processing algorithm. Or I can make a table of rotated versions of the image. Something else that's a symbolic expression in the Wolfram language is a user interface element, like a slider. I can make a whole grid of them, build up any user interface, all just represented by a symbolic expression. Same with documents and document elements too, all just symbolic. And once things are symbolic, it's easy to do meta operations on them, like take a plot and effectively just pick it up and make a dynamic version of it. You can make a dynamic version of anything. And because everything is a symbolic expression, it all just works. You know, any function can be treated symbolically. Here's just f, symbolic f. And actually, underneath, the full form of everything in the language is like this. Just a bunch of symbolic functions, representing formulas or data sets or documents or cities or whatever. So, what can you do with these symbolic functions? Well, one thing is incredibly powerful functional programming. Nest a function symbolically, or put more and more frames around something, or make a kind of nested interface. Okay, here's something more ambitious. Let's use functional programming to do some web crawling. The Wolfram language already knows how to import lots of things, like hyperlinks from my website. It's a little more code, but let's nestedly crawl out a couple of levels, then make a graph of what that corner of the web looks like. You know, you can make symbolic pure functions to do all sorts of things. Like this takes the list of English words that are built into the Wolfram language and creates a function to find which one is nearest to a given word. Now you can pick up this function and apply it to any word and make a simple spell corrector. Pure functions and functional programming get in everywhere. Here's selecting palindrome words based on a simple symbolic pure function. You can generalize this dramatically and, for example, get a shockingly powerful symbolic way to query databases and large hierarchical collections of data. In a sense, the Wolfram language is kind of the ultimate fusion language, because its symbolic nature lets it encompass pretty much any style of programming. One that's very powerful and kind of uniquely symbolic is pattern-based programming. The idea is you give a pattern for transforming some class of symbolic expressions. Like this says that any time there's f of some particular nested list structure, here's the value. So now if we give f this kind of structure, it'll produce a result. But if the pattern doesn't match, it'll just stay symbolic. And this is basically how all function definitions in the Wolfram language work. The Wolfram language is a huge language, by far the largest ever, but it's built on a small set of powerful principles. The first is coherence, the idea that everything in the language must fit together. I must say that I've spent a fair fraction of the past 30 years working to make this happen, designing every corner of the language so it's as consistent and unified and integrated as possible. So it's easy to understand, and so one can take something from over here and be confident that it'll feed right into something over there. I've had another principle too, maximum automation, the idea that the language should take care of as much as possible. Let's say you're doing machine learning and you want to build a data classifier. Well, there are all sorts of methods for doing that, but in the Wolfram language there's just one superfunction, classify, that's packed with meta-algorithms to automatically figure out what to do. Of course, if you want, you can go in and control every detail, but otherwise you can just treat it like a black box, one of thousands of superfunctions in the Wolfram language, that effectively give you the highest possible level building blocks for programs. And these building blocks don't just contain algorithms, they've got knowledge and data too. Knowledge about how to import and export hundreds of formats, knowledge about how to interact with all sorts of external APIs, knowledge about how to compute properties of systems in the world, and also huge amounts of curated computable data stored in the Wolfram cloud and continuously updated. The same data that powers Wolfram Alpha, completely programmatically accessible. But okay, so the Wolfram language makes it really easy to create really powerful programs. But what can you do with them? Well, it turns out that the symbolic nature of the language does something great here too, because it lets the language define and describe its own deployment. Let's say you set up a function in the Wolfram language. You can run it in your notebook session, or you can just take the symbolic code and deploy it to the cloud. You can just go to the cloud object from the web, and if you do, you'll see a web interface, which automatically runs your Wolfram language code in the cloud. And by the way, you can set up a mobile app to do the same kind of thing. The interface here uses CDF, our computable document format, running in the cloud. And in fact, you can run the whole native notebook interface for the Wolfram language in the cloud. Here it is. You can use notebooks as templates for reports that get filled in by running Wolfram language code. You can schedule Wolfram Language code to run on cloud servers at particular times, say sending you mail. You can take any Wolfram Language function and set up an instant API for it that you can call from anywhere on the web. Like this asks for a JSON output of some weather data for the user's geolocation. If you have an embedded Wolfram engine, you can get code to embed a call to this in lots of languages. And you can actually call the code without even going to the web. One thing about the Wolfram language is that it's completely scalable. You can write tiny one-line programs that are already very powerful, or you can write multi-million-line programs like Wolfram Alpha. It's so much easier to build and debug symbolic programs because at every stage, every piece is meaningful. And depending on your style of programming, there are various IDEs for the Wolfram language that take advantage of the symbolic character of the language. You can use the Wolfram language for high-performance computing, too. It's got parallelism built right into the language. So this is automatically starting up and running lots of different processes across my little heterogeneous network and collecting the results. You can also use the Wolfram language on the upcoming generation of tiny embedded processors. And for example, it's included with the OS for the Raspberry Pi Linux computer. You can use the Wolfram language to interact with devices. In fact, the Wolfram language is in a unique position with respect to devices and with respect to real-world data in general, because in a sense it's a language that has a model of the world built in. And in fact, WDF, the Wolfram Data Framework, encapsulates that model. And within the Wolfram language, there are lots of ways of taking unstructured data and getting it into WDF, with its units and dates and entities and so on made canonical. When it comes to devices, the Wolfram Connected Devices project is curating them to make them automatically accessible from within the language. Okay, so I've tried to give some indication of what the Wolfram language is about. So how can you get started? Like after every output, there's a suggestions bar that suggests what you might want to do next. And you can even try just giving input in natural language and starting to construct your programs that way. And when you've got a program you like, you can deploy it in all sorts of ways. My goal with the Wolfram language has been to encapsulate as much computation and knowledge as possible, so people can go from ideas to deployed products as quickly and easily as possible. I've also been very pleased that the Wolfram language seems to be uniquely good as a first programming language, because you can do so much so easily and quickly get exposed to such a broad range of methods and topics. I've been working towards the Wolfram language for 30 years. We laid strong foundations very early, and we've just kept on building. And actually, I keep on being amazed at what's possible. And now we've got a vast stack of technology and content that I think just completely changes how we should think about programming. I get a big kick out of using it every day. I hope you'll have a chance to try it, and that you'll end up doing amazing things with the Wolfram language. Thanks very much.